Hi everyone, this is a video for Map 105 on right triangle. In this video, we're going to look at right triangles and how we can solve for missing sides and missing angles in right triangles. So here's a picture of a right triangle. A couple of things I just want to point out first. We're going to call this triangle ABC because that's what that's what the angles are labeled as. But if you notice, all the angles are capital letters. And then if you look at the sides of the triangle, they're all lowercase. And that's always done that way so you can tell them apart when doing an algebra problem. You know whether A represents an angle side. The other thing that's very important is that go starting at angle A, if you go across the triangle, that brings you to side A. So the A's are opposite each other in the triangle. Angle A and side A, opposite pairs. The B, opposite B, side B. So those letters always get paired together, angle A and side A, angle B and side B. And the same thing with C as well. But the C is actually the most important one in this triangle. Because C, side C, are hypotenuse. The little description I have here is in a right triangle, side opposite the right angle, called the hypotenuse. And angle C is your right angle. That's what makes this a right triangle. Hypotenuse, always side opposite right angle. That's what makes this a right. So the first thing we're going to look at is Pythagorean. So so the Pythagorean theorem, by the way, all of the things we're doing in this video work for right triangles. If you want to solve for a missing side or angle for a triangle, not a right triangle, you have to use something different, like law of sines or law of cosines, other formulas that we're not covering in the Pythagorean only works for a right triangle. A and B are just any two sides, triangle, but C, the one that the equation is always the hypotenuse. That's the most important thing when setting up a problem. So if you look at the first one here, we have question one. We have two sides, 6, 8, and the hypotenuse x. That's what we're solving for. We're solving for the hypotenuse. And by the way, at any point in this video, feel free to try some of the problems on your own. Pause it, try it on your own. But I'm going to go through each of them step by step. So to find the missing side x, Pythagorean square plus b. Pythagorean theorem can help you solve for a missing side. So the 6 and the 8, those are going to be the A and the B. C, B, X. So 6 squared is 36. 8 squared is 4. We're adding those together, so you get 100. The 100, forgot to write. The 100 equals x squared. But we're trying to solve for x, so the next step, which what I have in green, take the square of both sides. Then the square of 100 is x equals. There you go. Go back to your picture. Looking at triangle number 2. So solving for x. X is not a hypotenuse. We actually already know what the hypotenuse is. The hypotenuse is 5. So when we use Pythagorean, most important thing to do, make sure that the C is the measure of the hypotenuse. Whether you know it or not, the value, what the equation's equal to, is hypotenuse. So we have 4 squared plus x squared, the hypotenuse 5 squared. Then so we have this 5, and then I'm going to subtract 16 both sides because the goal is to get x by itself. Then we want to take the square root of both. All right, so let's start talking about trigonometric ratios. This is now where we start to solve for angles, where Pythagorean theorem is strictly just talking about different sides of the triangle. SOHCAHTOA trig ratios is where we can talk about angles. And SOHCAHTOA is an acronym that reminds you of what each of the ratios represents. A ratio is just a fraction. That's all it is. So when we have sine of A. Notice that's a capital A, and the capital letters mean we're dealing with angles. So the sine of A, it's the ratio or fraction of the opposite side over hypotenuse. So we have sine being opposite over hypotenuse. You have the cosine. It's the ratio of the adjacent side of A over the hypotenuse. So cosine is adjacent over hypotenuse. And then your tan is opposite over adjacent. So if you look here, we have triangle ABC. C is the right angle. And the first question I have is, what is the side opposite angle A? So the side opposite angle A is side A. The side adjacent to A. Well, when it comes to being adjacent, we know what the opposite, either a side is opposite, adjacent, or hypotenuse. We know what the opposite is already. The hypotenuse is always opposite the right angle. So the hypotenuse is C. The only thing left for the adjacent side is B. And if you look at where it is, where it's placed, it's just right next to it. So it's adjacent to it. So you have your opposite, adjacent, and hypotenuse. So what is the sine of A? Well, the sine of A, let me rewrite that. So the sine of A, on the last slide, we said sine is the opposite side over the hypotenuse. So it's going to be the fraction of the opposite, which is A, over the hypotenuse, which is C. And we're just talking in terms of letters for now. But, if we knew that A was maybe 5 and B was 3, then that's what you would write instead of A and C. The cosine of A. So cosine is adjacent over hypotenuse. That's what we had on the last slide. So cosine of A is adjacent. So we know the adjacent is B, and the hypotenuse is C. And then the tan of A. So the tan is opposite over adjacent. The opposite side is A, and the adjacent is B. So tan of A is equal to A over B. Now, in the next slide, I want to do the same thing, but for angle B. Because depending on which angle you're talking about, the opposite adjacent is going to change. So what side is opposite angle B? Well, opposite angle B is side B. Adjacent to angle B is going to be A. And I didn't write it in here, but the hypotenuse is going to be C. And the hypotenuse, again, is always opposite the right angle. So if we want to do what is the sine of B, so sine of B, sine is always the opposite side over the hypotenuse. So here the opposite side is B, and the hypotenuse is C. Cosine of B, cosine is adjacent over hypotenuse. So the adjacent side is A, and the hypotenuse is C. Tan is opposite over adjacent. So opposite is B, and the adjacent is A. So those are our answers. All right, so for these questions, we want to find the trigonometric ratios for angle X. So angle X, I drew a little blue thing next to it so you can see it. So what we want to do is we want to figure out the sine, cosine, and tan for X. So now these sides of the triangles, they're not just letters, they have numbers to them. So the first one, or actually let's just label this first. If this is our angle, that means that 24 is the opposite. It means that 7 is the adjacent, and 25 is the hypotenuse. The opposite is always directly across where the angle is. The hypotenuse is always opposite the right angle, and the adjacent is the third one that's left. So if we want to do sine, sine is the opposite over hypotenuse, so it's the fraction of 24 over 25. Cosine is your adjacent over hypotenuse, so it's the 7 over 25. And then lastly, tan would be the 24 over 7, your opposite over adjacent. Looking at the next triangle, so we have x here, so that means, that means that 48 is the opposite because it's directly across the angle. 14 is adjacent because it's right next to the angle. And 50 is the hypotenuse. 50 is the hypotenuse because it is directly across the right angle and it's the longest side of your triangle. The hypotenuse is always the longest side. So if we want to do the sine is opposite over hypotenuse, the 48 over 50. Cosine is adjacent over hypotenuse, so 14 over 50. And tan is opposite over adjacent, the 48 over 14. All right, so one thing that we can do is figure out what if we know what the angle is, we can do the tan, the sine, and the cosine of that angle. So instead of just writing it as the sine of A or a cosine of B, if you know what the angle is, you can take your calculator and type that in. So if you have a calculator, please do this. You need a scientific calculator. And it depends on what calculator you have. If it's a scientific or a TI-84, you would actually type in the sine, cosine, or tan. You would hit that button first and then type in the number. If you're using your phone, usually you have to type in the angle and then you can hit the sine, cosine, or tan angle. If you have a degree or radians setting on your calculator, make sure it's set for degrees. The way you do that depends on which calculator model you're using. You can always look that up online if you need help figuring out how to do that. It really just depends on which calculator you have. But if you're to type in the tan of 20, the angle, the answer you should be getting is 0.3640. And the decimal, it continues on. I'm just going to round it to 4 decimal places. That's pretty typical in trigonometry. In your calculator, the tan of 11 degrees is 0.1944. And what that is actually is every decimal can be written as a fraction, unless it's an irrational number. But all of these answers can be written as fractions. And that's actually what we were doing in the previous slide. We were writing the sine, cosine, and tan as ratios, as fractions. So if you were to divide those fractions and see what the decimal is, you would get something similar to what we're doing right now. So that's where these decimals are coming from. They're fractions that you're writing for some triangle that someone created. The sine of 45 is 0.9654. The cosine of 65 is 0.4226. This is just purely in the calculator, so just spend the time to make sure you know how to use the calculator to find these answers. But now, this is really what I was leading up to. So with Pythagorean theorem, we were able to use that to solve for missing sides. For these trig ratios with SOHCAHTOA, we can use it to help us solve for missing angles, if we already know what the sides are. So this is what it says. We can use right triangle trigonometry to find one of the acute angles if we know the trig ratio, if we know the sides and can write a fraction for it. So let's say that tan of theta is equal to 1. 1 divided by 1. Let's say it's equal to 1. We can solve for that angle, and our calculator can do that for us. So this is using our scientific or graphing calculator. What you want to use is the inverse button. On a TI-84 calculator, you would hit the second button and then the tan. You would do a similar thing on a scientific calculator. You hit second and then tan. I believe it's actually its own button if you're using your phone. But if you were to type in the inverse tan of 1, you would press the inverse tan button of 1. It's actually going to give you 45. That means the angle is 45 degrees. So for a triangle, if you have an angle of 45 degrees, that means the ratio is going to be 1 over 1. And this is what our calculator can do for us. It can help us solve for these missing angles. So I have a bunch of examples here that we can do. Feel free to try them on your own if you want. I'm going to go over all 4 of them in just a moment. Each of these say find the measure of the indicated angle to the nearest degree. So if you look at the triangles for number 9, we have our angle, that's the question mark. The 12, that's the adjacent side. And the 44, that is your hypotenuse, because the 44 is opposite the right angle. So the trig ratio that we can write is that cosine of x, we'll call that missing angle x, is 12 over 44. And the reason I'm using cosine, I wrote it as cosine of x, is because we have the adjacent and we have the hypotenuse. And the trig ratio that we have for taking an adjacent and hypotenuse and writing it as a fraction is cosine. Cosine is taking the adjacent and hypotenuse. So now, in your calculator, you can do, well, I'll block that first. You can do the inverse cosine of 12 over 44. And if you type that into your calculator, it's going to give you 74 degrees. Rounded to the nearest degree, it rounds to 74. Um, so I just want you to understand that if you have 2 sides of a triangle, and you know what they are, you know that one is an adjacent hypotenuse or one is opposite. If you know what it is in relation to the triangle, you can use this inverse feature, the second button, to figure out the actual angle. Looking at number 10, we have our angle here, we'll call it angle x. So then the 22 is the adjacent, and the 10 is opposite. The 10 is opposite. So the trig ratio that we have that deals with opposite and adjacent is tan. So the tan of this missing angle is equal to 10 over 22, the opposite over the adjacent. And if you type in your calculator, the inverse tan, second tan of 10 over 22, your calculator will tell you that the answer, the angle, is about 24 degrees. Pythagorean theorem helped us solve for missing sides of a triangle. These trig ratios, sine, cosine, and tan, can help you solve for the missing angles. This next one. So we have our angle x, this is your opposite, and this is your hypotenuse. So the trig ratio that deals with opposite and hypotenuse is sine, because sine is opposite over hypotenuse. So the sine of x is equal to 38 over 45. You can type this into your calculator, and the calculator will tell you that the angle for this ratio is 58 degrees. Also, make sure when you're writing the angle, include the little circle to indicate its degrees, because there is more than one way of measuring angle measure, and it's really just a way of including your units, because we're in terms of degrees. Last one. So this is x. This is the adjacent, 10 is adjacent. 33 is hypotenuse, because that's opposite the right angle. Adjacent and hypotenuse, that's dealing with cosine. Cosine is the ratio of the adjacent over hypotenuse. So the cosine of the adjacent over hypotenuse, cosine of 10 over 33, is written as such, and we can do the inverse of that in our calculator. So the second cosine, inverse cosine of 10 over 33 is 72 degrees. All right, so here's our last problem. It's a word problem. It says the angle of elevation to the top of a tree from a point on the ground. Let me just pause there. Angle of elevation is just an angle from the ground level looking up. So you can see we have this little arrow right here showing you that from the ground level looking up to the sky, looking to the top of this tree, you're creating this angle where from the ground level, you're looking at this point. So that's an angle of elevation from the ground just looking up into the air at a certain point. It then says that you have a distance of 42 feet. And also add the units here. So you got 42 feet from the point of where you're standing to the base of the tree. So that's 42 feet. And the angle of elevation is 33 degrees. And we want to find the height of this tree to the nearest foot. So we actually just have a triangle right here. And if we have our angle of elevation, which is 33 degrees, the h is the opposite side of that angle. The 42 is your adjacent. So we have our adjacent, we have an opposite. So when you have adjacent and opposite together, that's the trig ratio for tan. So we can say that the tan of our angle is the opposite side over the adjacent, which is 42. So this problem is a little bit different from the previous ones. We know the angle, we have the 42, but the opposite side we don't actually know what it is for. That's what we're solving for. And the way you can solve this is by multiplying both sides of the equation by 42, because then these 42s will divide out. And then you have 42 times the tan of 33 equal to h. And all you have to do now is type that into your calculator. I believe, oh, I'm looking for my calculator right now. So with this, again, make sure you're in degree mode. Make sure you're comfortable with using your calculator for this. But when you do 42 times the tan of 33, you might have to type in the tan of 33 first and then multiply 42. But the answer you get is 27.28 about. But they're saying round to the nearest foot. So we're going to say this is 27 feet. That's our final answer. All right, I hope this video helped. Thank you for watching. If you have any questions, you can send me an email or you can ask me at the next lecture. So thank you for watching and I'll see you next time. Bye-bye.